Hey guys, welcome back to Unit 7 for the ICP Final Study Guide for Semester 2. Let's start with Unit 7, Stoichiometry. It's a very short unit, on the study guide at least. And yeah, let's get started. Question 1 asks, what is stoichiometry, right? We gotta know what stoichiometry even means to do it, right? Stoichiometry is, figuring out the proportions of elements and compounds and how they react with one another. And so I'm just trying to come up with an easy definition for you guys. So definition, like, I don't know, we'll just call it a relationship. How's that? Of course, the definition is subjective, so take away what you need to. So we can say the relationship between the quantities of substances in a chemical reaction. I'm trying to write small here so we have space for question 2. Reaction typically with whole number ratios. Alright, they didn't give us much space to write here, but I'm sure the actual space on the paper you received in class was greater. So yeah, that is the basic definition of stoichiometry. So let's get started with mole ratio, a key concept of stoichiometry. Question 2. A mole ratio is the ratio of two compounds in a balanced chemical reaction, right? We'll just write the ratio of any two, it can be any two compounds in moles, right? It's called mole ratio for a reason. It has to be moles in moles. All right. And so what we kind of answered this by saying it, but where do the numbers come from the mole ratio? A balanced chemical reaction. Balanced chemical reaction. All right. Question 4 says, calculate the total molar mass of Al2S3. Remember what I drilled into you guys the whole second semester. What is the unit for molar mass? Grams per mole. Keep that in mind for later on. So it asks us to find the molar mass of Al2S3, right? And that number will come from the periodic table. So let's move over here to the periodic table, and we're asked to find the molar mass of Al2S3. So where is Al? It's going to be right there. And where is S3? It is going to be right there. Well, S, it's going to be right there. So in order to calculate this, right, let's write this a little differently. Al2S3 is what we're trying to find here. So Al, that number down there, that is going to be your molar mass, right? So how many of these Als in our compound do we have? We have 2. So each one single Al is 26.98, but we have 2 of these, so we have to multiply it by 2. Right? Do that first. Let's put that aside. And we have how many S's? We have 3 times 32.06, the number you got from right there. That's for one S. We have 3 S's in here. That's why we have to multiply it by 3. So go ahead and grab out your calculator and let's calculate this. 2 times 26.98 will give you 53.96, plus we have 3 times 32.06, which will give you 96.18. And if you add 53.96 to 96.18, right, this plus this, you're going to get a total number that is 150.14. And of course, what did we say the unit for molar mass would be? That, grams per mole, right? Grams per mole. That is our unit for molar mass. And so that is our answer. So we're going to go in and copy that down on this side here. 150.14 grams per mole is our final answer. Last but not least, question 5 says, how many grams of aluminum oxide, Al2, let's write that in a different color. We'll do purple. I feel like purple. Alright, aluminum oxide. How many grams of aluminum oxide, right? Al2O3 are required to react completely with 14.8 grams of O2 when given the reaction this. Of course, this doesn't look very balanced to me. So let's go ahead and do that first, right? This is a classic synthesis reaction, but of course you do not need to know that. For this unit at least, you needed to know for unit 6 if you watched the video on that. And we know it's synthesis because we have two separate compounds form into one. So all that aside, this is the stoichiometry unit. Let's focus on the actual stoic. How many ALs do we have on the left hand side of the arrow? We have 1. How many do we have on the right hand side? We have 2, so the number here has to be 2. How many oxygens do we have on here, and how many do we have here? 2 on the left hand side and 3 on the right hand side. They're not even numbers, so you have to multiply them by each other. 2 times 3 is 6. 3 times 2 is 6. This, however, changes the amount of aluminum. 2 times 2 is 4, so that number there needs to be a 4, and now we are balanced. And using this balanced chemical reaction, we can use mole ratio to solve this question. So we always start with what we are given, 14.8 grams of O2. Time sign, draw a line, of course. And so what do we need to put on the bottom? Well, we need to put the gram value. We're going to use grams per mole. Remember this from earlier? Where that is going to be our conversion factor for this case. Each oxygen has 16 grams per mole. O2 has 32. 32 grams of O2 per 1 mole of O2. Time sign, draw a line. For every 3 moles of O2 in our balanced chemical reaction, moles of O2. For every 3 moles of O2, what are we trying to get to? We're trying to get to Al2O3. For every 3 moles of O2, we're going to have 2 moles of Al2O3. 2 moles of Al2O3. Right? And we have to ultimately end up with grams of aluminum oxide, right? So we're going to use the molar mass for aluminum oxide. So for every 1 mole of aluminum oxide, we're going to have some grams of aluminum oxide. That'll get us to grams. Let's calculate the molar mass of aluminum oxide real quick. So we can here. Let's use our periodic table again. Smart idea. All right, Al2O3 is what we're trying to find. Erase all that real quick. Aluminum and oxygen. Al2O3. So this, we have two aluminums, 26.98, plus we have 3 oxygens, 3 times 16. That is going to be, if you plug it into your calculator, 2 times 26.98 will give you 53.96. And then 3 times 16 will of course give you 3 times 16 will give you 48. And 48 plus 53.96 will give you 101. So you add these together to get 101.96 grams per mole. That is going to be the number, the magic number that we use. Zoom in back again. And so the molar mass, we're just going to call mm, is going to be 101.96 grams per mole. That number goes right there on top. And all we have to do now is multiply everything by the top and divide by everything on the bottom. So let's go ahead and do that. So grab out your calculator, plug in 14.8 times 1 times 2 times a 101.96. That will give you 3018.016 on top. Divide that by everything on the bottom, so divide it by 1, divide it by 32, divide it by 3. And of course another 1, but of course dividing by 1 doesn't get you anywhere. So that, doing all that will give you 31.43, and we'll round to the hundredths place. So 31.44 grams of aluminum oxide, which is your final answer. There we go. That brings it to the end of the stoichiometry unit. Let's go ahead and mark up some of the most important concepts we covered here. This is the mole ratio from balanced chemical, here, let's write that out. Balanced, I'm so nice. Balanced chemical reaction, chemical equation. And this here is going to be, here, let's point it towards that, molar mass. So those two are the most important concepts that we used here today. We used the mole ratio and molar mass in order to get to where we need to go. Thanks for watching Unit 7. We'll see you back in Unit 8, the second to last unit for the final study guide. Alright.